Okay, welcome guys. Today we are going to talk about Twitter use case in which how Twitter solved the problem of fanning out of tweets. Problem of fanning out of tweets. Okay, so for Twitter, mostly there are two use cases. One use case is post tweet, and the second use case is home timeline. So in case of post tweet, what happens is a user publishes a message or a tweet, and in case of home timeline, what happens is the user is able to view the tweets. Now we need to think about the scale of the post tweet and the scale of home timeline. So uh, 5k request per second is a scale in average case in which a user posts a tweet. In case of peak hours, it could range to 12k request per second. Okay, and in this case, the view is more. So it is 300k request per second. Okay, so these are the two use cases uh, for which we would want to solve the problem. Okay, now there are two ways of solving this problem. First way is that you have a global tweet. So in this approach one, what you do is you kind of store the tweet. So you have a table which is follower ID, followee ID, okay, and then you have relation with the user table. Okay. So let's say X is the follower ID, Y is somebody who posted the tweet, Y is the user, the name of the user, and then you also have a tweet in which you have the ID of the tweet, let's say, and then you have the sender name or the sender ID. In this case, let's say Y tweets, at what time the Y tweets. So this is something that you have. Now, what happens is when you write it in the global tweet table. So write is cheap. But when you read, what you need to do is you need to fan this out. So for a particular user, a user will see what are the followers the user has. So how many followers the user has. For each follower, it will be in the timeline of those followers that that tweet will be displayed. So in that case, if let's say somebody wants to read, then the user will have to span. So we need to do slide tweet dot star user dot star from tweets join users on tweet dot sender id is equals to user dot id join. Let's say this table is follows on follows dot follow eid equals to user dot id where follows dot followee id equals to the current user for which we want to tweet. So here you see the read is very expensive. Okay, so this is the first approach in which the writes are cheap and the reads are expensive. The second approach is in which you kind of maintain a cache. Okay, so whenever we are writing, we write it in the timeline of all the people that y follows. So let's say y follows a, b, and x. So we'll write in the timeline of a, we'll write in the timeline of b, and we'll write in the timeline of x. So whenever there is a read from a, we will fetch it from the timeline or from the cache and then return the result. So in this case, the write that is happening is expensive. But when you do a read, you just have to fetch it from the cache. Okay. So let's say if a user tweets T1, T2, then this will be fanned out to each of the users. Let's say this is the user X and X follows A, X follows B, X follows X. So this will be fanned out in each of users timeline. Okay. Okay. So in the first, there is a issue that the writes are cheap, but the reads are very expensive. And in second, there is the issue that if let's say user X has billions of followers, in that case, during the write, this has to update the timeline for each of the user, which could be a costly affair. So what Twitter did was Twitter found a middle ground in which, for most of the cases, they would want to use approach one, in which, for most of the cases, they would want to use approach two. And for some of the cases where there are a lot of followers for a particular person, let's say the person is a celebrity, in that case, the approach that will be used is approach one. So, in case of, let's say, a celebrity, it will be approach one. But for most of the people, it will be approach two that will be followed. Okay, I think that's it. Thank you, guys.